Hello everyone, welcome back. So in this video we'll establish the relationship between maximum amplitude of electric field vector and magnetic field vector in an electromagnetic wave. We know that in an electromagnetic wave, the electric field and magnetic field both propagate together with mutually perpendicular, and we know that from Gauss law that your integration E dot ds is equal to minus delta phi b by dt. That is the rate of change of flux. Gauss law can be written in this way because we know that rate of change of flux is the EMF induced in a coil that we know in a Gauss law, and also we can express E ds is equal to also EMF, so that we can write E dot ds integration of E ds is equal to minus d phi by dt, where phi b is the flux. Now what we will prove this from this relationship? We will prove that the EM by BM, the ratio of the amplitude of the electric field divided by magnetic field, the amplitude is equal to a constant, that is a C. So this is what we are going to prove today, and we'll start from this one, right? Let's take, as I told you, both electric field and magnetic field, they move mutually perpendicular to each other. So let's say the electromagnetic wave, it's moving like this. Both electric and magnetic field vectors are there. Magnetic field, they are mutually propagating, and let's say they are propagating towards z axis, and this is your electric field is in x axis and magnetic field is in y axis. It is oscillating about y axis and electric field is oscillating about x axis. So how we'll represent the vector? So I'll write the vector electric field, it's oscillating about x axis, so I'll write Ex equal to Em, that the maximum amplitude of the electric field vector, and sine kz minus omega t. K is the wave vector and it is propagating along z axis, so kz minus omega t is the angular frequency, angular velocity, and t is the time. So Bx also I'll write in similar way, Bm sin kz minus omega t. This is the waveform. We represent wave like this and it's propagating in z direction, and this is the wave vector k, and where k is equal to 2 pi by lambda, k equal to 2 pi by lambda, and omega equal to 2 pi by time period. These things we know, right? Now let's say a rectangular piece part is there and having point P. So this wave will pass through this rectangle, let's say, and the area of the rectangle, let's say this is dx, and this rectangle has, let's say, height h, right? So when this electromagnetic wave is propagating, let's say when the electric field will pass, let's say this is d E plus dE here, okay? So one phase it will be E, another phase, let's say it's E plus delta E, the electric field strength, okay? So we'll face one phase will have electric field, means it will when it will pass through, right? Another phase will be E plus dE. So this integration we can write that E plus delta E H minus EH, because integration is nothing just but the area under the curve. So here within this area, what will be the one side, this difference of this area? So one side will have E plus delta E into H, and or you can say subtract, so this one multiplication here H. So this is what your EDS, this is what your EDX, and if you subtract you will get exactly HDE. Okay, so this is your integration of your left side. Now what will be the flux? The area is HDX, right? The area of this rectangle is HDX. dx is the width of the rectangle, right? So if I'll write that area is EDX, so what you can write, because what is the flux? Flux is, we know that it's BA, magnetic field with area, so area is HDX here. Okay, so flux is BHDX. So what will be d phi by dt? It will be BH are constant, let's say, so BH dx, sorry, not B is not constant, B is moving, so here H dx, your dB by dt. dx is very small one, right? dx is not changing, it's the width, so dB by dt, right? d phi by dt, rate of change of flux, is equal to this one, and your EDS integration is this one. So let's say this is equation 1, then equation 2. So from 1 and 2 you can write that, this is right, you can write that from 1 and 2 you can write that minus or HDE equal to this one, and this is minus, so minus H dx dV by dt, right? You can write this. Now HH get cancelled and dx I'll cross multiply, so I'll write like this, dE by dx equal to minus dB by dt. Now E and B are as in this form, and E is changing with x, okay, E will change with x when it is crossing x, so T will be constant for that. That means we are taking a snapshot of this one or for a constant time. Okay, this one we are finding out for a fraction of time, this one, and means fixing your, or you can change this. Okay, so propagation Z means you can do it all these things Z, or you can make it okay, so some change will be there, this will be XX, the propagation I have changed to X. Okay, so it will be better, and this will be EZ you can write. Okay, EZ you can write, Z and okay, this is Y EZ and BY, no issue, you can write. Okay, So but E cross B should come in that direction. E cross B should be X. So is Z cross Y is X. So X, Y, Z. Z cross Y cross Z is. So you can do one thing, right? You can write E, Y and B, Z. It's better, right? Because E cross B should come in positive X direction, else it will be in negative direction, right? E cross B vector, right? So this is your dE upon dx is delta. Now we'll calculate this differentiate keeping time fixed, because this E will be at a fixed time. E will be at a fixed time, and we'll keep the time constant here. And B, for B we are finding out with respect to time, and X will be fixed for B. The change will be less for this X, okay, but with respect to time you will get will get the magnetic field. So what we can do, instead of this differentiation, we can find out partial differentiation. You know how to calculate the partial differentiation. The mathematics students, you know partial differentiation means suppose we are finding out dE by dx, we'll only find out we'll only differentiate with respect to x. Other terms like t is a variable, this function, this is a function of two variables, x and t both are variables, right? But we'll fix one term, like we'll fix t and we'll find out we'll differentiate this one along with x only. So we'll convert this differential to partial differentiation. We can write partial differentiation for this, right? So what we can write for that, we can write that we'll convert it into partial differentiation. So we can write that, or we can erase and write. So we'll write we'll write that delta symbol we use generally, delta E by delta X equal to minus delta B by delta T. So this is the partial differentiation, and the E and B will bring here and will put, right? So basically this is EY and BZ we are doing it. So EY, if we'll put, this will be BM, this will be E. So EM is there, differentiation you can do EM, and sine will become cos, and cos term will come out. Cos term will, it will be cos term, k will come out of this one. So k cos kx minus omega t, right? Not omega t, okay, kx minus omega t, okay, kx minus omega t, and this term again you will differentiate, then omega t will become 0, only k terms will be there, equal to, if you differentiate this one, what you will get, this one again, let me do here, so minus, here if you differentiate, but here we are differentiating with respect to t, you remember. So t term will be, omega will come outside, minus omega will come outside, not kx, k will not come out, okay. So here BM omega, BM omega, okay, and cos minus omega, so it will become plus kx minus omega t. So cos kx minus cos k minus omega t will cancel out. Omega upon k, omega upon k. So what we are getting here, just you Notice, see, so what we are getting? We are getting EMK equal to BM omega. Okay, and what is K? 2 pi by lambda, and omega is 2 pi by T. So what will be omega by K? Omega by K would be the speed of the wave, the speed of the electromagnetic wave. How can it be? Just you can divide. This is 2 pi by T and K is 2 pi by lambda. So it is lambda by T. Lambda by T will be, this is a distance, this is a time. So dimensionally this will be your velocity of vector V. Okay, this will be V. So omega by K is your velocity V, but here it is the velocity of this one is C. Okay, speed of light. So this is your C. So we can write this E M equal to Bm omega by K, or we can say Bm C, or here we can write that, EM by, here we can write EM by Bm, that is the amplitude of electric field divided by amplitude of magnetic field is equal to C. So this is a proof of this, and very important result. Many times the question comes in different entrance examinations, and this one also one important result that you should also note down, that omega by K is lambda by T is C. Okay, omega by K is C, and also you can say this is omega by K lambda by T equal to C, and 1 upon T is frequency, right? 1 upon time period is frequency, so you can say lambda F equal to C also. Okay. So this relationship is very important, and many times you need to solve means in different numericals you have to use these formulas to solve them, right? So I hope it's clear. If it is not clear, you can write in the comment box, so we can discuss sometime later. I can discuss again, right? Thank you for watching the video. See you in another video. Bye bye. Take care.